All right, so let's say we have dinner and you get to choose an entree, a side item, and a dessert, and your choices are independent. All right, so what you choose for your entree is not going to change the probability of your side item, which is not going to change the probability of your dessert item. All right, so what's the probability that a person chooses a vegetarian entree, V, and they choose broccoli, and they choose apple pie? Well, since that we were told they're independent, and we would have to be told this because we would not guess they were independent, because they're not. They wouldn't be. But this is the probability of V times the probability of B times the probability of A. All right, so we just take the first one. Here's my vegetarian, 10%. That's 0.1. Here's my broccoli, 60%. That's going to be 0.6. 55 chocolate cheesecake, 35% choose apple pie. This will be 0.35. All right, so 0.1 times 0.6 times 0.35. This happens to be 0.021. What happened? There we go. All right, so I just multiplied the three probabilities. They're independent, so we can do that. Now, what if we hadn't said that they were independent? What if we were told they're not independent, which is more likely, meaning somebody who chose steak as an entree is probably more likely to choose a baked potato for their side than somebody who chose a vegetarian entree. Someone who's choosing a vegetarian entree is probably more health focused, and broccoli is more healthy for you than a baked potato. I'm sorry to tell you, I know. It's a sad reality, but that's how it is. I happen to like broccoli, but baked potato is pretty good, especially if you put butter and sour cream on it. But somebody who's vegetarian might not do that, all right? So knowing that you chose a vegetarian entree can affect the probability of what your side is and what your dessert is. And in which case, if I wanted to know this probability, I would need more information. Because okay, that was weird. All right. So I would need more information to calculate that probability. I would need to know, given that you would choose a vegetarian meal, what's the probability you choose broccoli? Maybe for that person, for this group of people, maybe 85% would choose broccoli. And then for people who chose vegetarian and broccoli, maybe the probability they choose apple pie, maybe it's a little bit bigger, or maybe it's less. Okay, but I would have to know those other probabilities to answer this question. Okay, another example. And this is, I got this off somewhere. So 53% believe men have it easier than women. And I can forget the also. I copied and pasted it from somewhere. So over half of the women think men have it easier than women. I'm not saying it's true. That's just how people feel. I don't know. I'd have to really think about that one before I answered it. All right. So if we asked two random women what they thought, what is the probability they both believe that men have it easier? All right. So basically I got to ask myself, are two random women, are they independent? And the answer is yes. And this is going to be always true. This will always be true for random samples, random selection. So when I'm selecting randomly, the people in that sample, the people that I randomly ask, will be independent of each other, their opinions, their ages, or whatever it is. Because I'm using a random process, one is not related to the other, okay? So yes, they're independent, which means that the probability that they both believe, first one believes and the second one believes, is the probability that a person believes squared So this would be 0.53 squared, and that is equal to 0.281. So if 53% believe, the probability that 2 randomly chosen believe is around 28%. All right, what if we asked 6 women? Would it be unusual that all 6 believed it? All right, so okay, let's look. So now the probability that 6 of them believe, all 6 believe, all right, this is going to be the probability believed to the 6th power. So this is 0.53 to the 6, which is kind of like approximately equal to the coin flipping. Oh, not that one. 0.022. Is it unusual? And we're going to say yes. And why is that? Because 0.022 is less than what percent, or less than what? You guys know? Think about it. What is it? So in statistics, we call an unusual probability one that is less than 0.05. So if it's less than 0.05, it's unusual. And if it's bigger, we say it's not unusual.